Hi everybody, here's Christian from Team Orcast. Welcome to our Pico-8 tutorial, where we are going to do a breakout arcana clone thing for complete newbies. Like, this is like so basic. Oh my gosh. Yeah. I'm gonna load our rickroll. I'm gonna look what happened last time around. All right, we got the heart. Heart is like changing colors. That's really sweet. Oh, I haven't saved the last things. Oh no, I did a reboot and I haven't saved. Well, that's never mind, because we are going to actually start from scratch today. We had this rickroll program for a while here, and this is really great. I love it. This is beautiful. But you know what? We're gonna start our program, our game for reals now, for reals. There's a question in the chat if these episodes are coming to YouTube. Yes, I'm recording them for YouTube tonight now, but I'm recording it with a live audience. If there's people who are watching live and have questions live, I can answer them immediately. Right, I made a huge mistake. You always should save your work. I haven't saved my work. No big deal though. We are going to start something from scratch. So I'm gonna go save. I'm gonna call this my breakout. Right. So now, as you can see, I have my breakout and my old rickroll program. I just basically like create a new file with the same content, and this is now where we do some cleanup. So the poo and pee is really funny, but I think we're gonna have to calm down and go with X and Y. In fact, this is gonna be our ball. So let's call it ball X, ball underscore X, and ball underscore Y. It's sometimes, I have to admit, it's useful to make the variables actually, you know, so you know and you understand what the variables are. We don't need the awesome variable anymore. The init function is okay. We're just gonna put its CLS in here just in case. The update function here. So yeah, we have ball X. We're gonna go ball X. We're gonna go dx. Dx. There we go. It's 1, and ball underscore dy equals 1. That was the poo speed and p speed that we had in previous things. D is usually something that you use for delta, how much something changes over time. That's a delta. So delta x and delta y. So these Fourier variables are controlling our ball. It's exactly the same thing as we had down here with a poo and p. Again, we're just changing the names so they are a little bit more readable. We're gonna go ball x equals ball x plus ball dx, and the same thing with the y as well. And we're not checking for collisions with the screen just yet, but it's okay. Instead of printing the heart, I really like the heart. Don't get me wrong, I really love the heart. But I think we're gonna have to draw a circle because we want to go for a ball. We're gonna have a ball. So let me see. Again, I have my cheat sheet here. I always use the cheat sheet. I'm gonna put it in doobly-doo again if you want to. It's in German. I'm gonna maybe translate it because there's also little things I don't like about a cheat sheet. I'm gonna totally go for my own cheat sheet when I release these on YouTube. And if you look at the cheat sheet, can you read it? There's like functions here, I think. Yeah, it's here. There are functions, documented functions that show you exactly how you draw different shapes. You can draw rectangles and circles, and we totally need a circle right now. So that's circfill. Circfill. This means we're drawing a filled circle. That's a ball. And so you have to put in the center of the circle first. That's going to be ball underscore x and ball underscore y. It's the same thing as we did in print, just the x and y coordinate, the left top coordinate. And then, because a circle has a radius, and then it's going to be 3. Oh, maybe at some point we're going to change the radius of the of the ball. So you know what? Let's call this ball underscore r for radius. We're going to set it to 3. Not sure if 3 is a good number. Maybe 2 is a better number. Let's see how this works. We're gonna change this later on. Ball under the circle is called 3. There we go. And then the last one is gonna be the color of the circle. This time around, I'm just not gonna mess around. Just gonna set it to 10. Again, there's a color indicator here. That's 10 is yellow. It was all yellow. I think if there's a sneeze coming on. So if you run this now, you can see, oh, that's a tiny ball. You can see the tiny ball going on the screen. Oh, ball underscore 3. That's wrong. Ball underscore R. There we go. It's a bit too big. So let me reduce the radius to 2. Do I like it? What happens if we reduce it to 1? That's a little bit tiny. What we can also, by the way, we can do 1.3. Not better. See, the problem is, like, of course, we have pixel. Yeah, this is like these are very, very rough pixels. So going 1.8, it's a half pixel. It's not anti-alias or anything. So you won't actually see a difference between 1 and 1.8. It's still the same because, you know, it just snaps to pixel sizes. Let's go with 2. It's a bit big. It seems a bit big, but it's actually a shape that looks like a ball to me. So, you know, it's going to be a bit of a chunky game. Right. So as you can see, it's bad because it leaves the screen. I don't like it. We're gonna fix this right away, but you know what? Something I wanted to also show. Remember how we put CLS in the draw function? And I told you, like, we need this because it gets messy if we don't do this. Well, let me put 2 minus in the front to commentate this out. Very, very useful thing. If you just want to disable one line of code, and it's like, what happens if I don't do this? You can just put 2 minus in front, and then it will comment this out. It will turn into comment. Right, so if you run this, you can see, oh, what happened there? Well, basically, every frame we're drawing a circle, right? And the next frame, we draw another circle on top of it. We don't clear the screen on every frame. So that's why it, like, leaves this smudge behind. And this is really nice. This is something I really enjoy, especially if you go like with, remember how we had the colors changing? Well, how about we do that now as well? Right? How about we add colors to this? So instead of the 10, we have color. Oh, beautiful. How beautiful. Right. So this is a kind of cool trick, and that's one of the reasons why I really like Pico-8. It's like really bare bones. You can get away with those kind of tricks, and you can saw maybe there was one demo where you were painting on the screen and there was like paint running down. That was done with this kind of like effect. You don't redraw the screen every time, you just add something to the screen. You know, like a painter. Like a painter doesn't just like print out something. You know, they do it, you know, piece by piece by piece. Every time they add something to it, and it's kind of like the same thing. And CLS wipes the screen. So if you do that now, it just pulsates because every time we clear the screen and draw a new circle from scratch. Just so you understand how this works. Right. So let me out at the bouncy thing again. Maybe like it's a good moment to repeat if, and then comes a statement that's either true or false. So if ball underscore x is greater than 127, then and end. And then we're gonna do this with is smaller than 0. And in this case, ball dx is equals 1. No, actually -1. And ball dx equals 1 if it hits the other edge of the screen. And then again, we copy these because these are for the x coordinates, and now we can change this for y. And now we can see why just working with x and y is a little bit easier. Sometimes we could just exchange all the x's into y's. And if you run this, it bounces off the screen. This is a bit silly now because it always goes diagonally, so it always bounces between the corners. It's not as exciting as it could be. So I'm gonna put the starting coordinates somewhere weird. Way better. Oh, look at this. Bam, bam, bam. And now, of course, as well, remember how we didn't clear the screen? We can add this now. Now we have a beautiful screensaver. Actually, it turns into a square, whatever we do. Can we break this? Can we make this? It will repeat eventually, but can we make it more interesting, like 33 or something? Let's see. I think it will just turn into a rectangle now. Yeah, because we're working with a square screen, and so it always goes around this pattern. Something to keep in mind when we're gonna go developing this game, we're gonna have to add something to make the ball go like maybe at different angles, so it's there's more variety to how the ball moves. All right, so before we continue, because there's this huge block of text here right now, I wanted to do some little changes, little tweaks, and also introduce you to some more advanced concepts about the if statement, because the if statement is here to stay, guys. If you don't like this, bad times, bad news for you guys. This will stay, and we are gonna have a lot of if statements in programming in general. Right. So did you notice how we have like a lot of if statements here, right? There's like a lot going on here. This is kind of like difficult to read here. There's like a lot of things you have to scroll through. Well, you can combine multiple if statements into one. So, and you can do this like with and. So I'm gonna do something crazy. I'm gonna take this statement down here. If ball is greater than 128, oh, actually not and, or smaller than 0, right? And the problem is, of course, is like, wait a minute, but different things happen when it collides with the left wall or right wall. How can we combine the two? Well, there is actually a very nice thing you can do here. You can go ball underscore dx equals minus ball underscore dx. So if it's negative, it will become positive, and if it's positive, it will become negative. Why are we doing this? Well, first of all, it's more compact to do this. Like there's less code now. We did the same thing with less code. That's good. Something to keep in mind here, down here, that's tokens. It says token count when you mouse over this. We are using 82 of 8,192. Every word you write, like, for example, the if I remove the if, we save 1 token. Well, we need that if, so we have to keep it in here. This is the limit. You can't have more words in a program than 8,192. Which for us won't be a problem, like we're not going to hit the limit, whatever. But, you know, it's a harsh limitation of the Pico-8 system, and if you have very complicated games, you might run into this. I'm currently working on a game that has like 4,000 or 6,000 or something, and I'm like really struggling and really trying to save every single word. Not something to get stressed out about, but usually there's a lot of reasons to make sure that you're doing things with as little code as possible. In our case, there's also another hidden advantage where it's like, remember how like down here we had to write down the speed, like spell out the speed every time, right? Now that we don't have the speed in here, it means that we can, for example, here start with a higher speed and it won't change. Let me first take this code and rewrite this for y as well, just so you understand what I mean. I'm gonna overwrite the second if statement. I'm gonna exchange everything with y's. Right. So first of all, I'm gonna set dx to 1 and dy to 1. I'm gonna test the code. Maybe it's broken. You know, you always have to test new code. But it seems to be working. But it's moving a bit slowly, so maybe we want to have it faster. Let me set the dx. Maybe we should actually so it's a bit better readable. So now let's make the ball move faster. So now it's moving twice as fast, 2 pixels every. Ah, see? And now you can make it really fast. It actually doesn't change speed. The if statement doesn't care how fast it's moving. It's just flipping it around, you know. You can make it go really, really fast. So this is nice because we don't have to actually... the if statement is agnostic about the speed of the ball now. So hidden advantage. Not only is it shorter, but it's actually also easier to manage. In the previous code, if you want to change the speed, we'd have to change it here and also down here in the if statement. Ugh. Cool. What are we going to do next? What do you guys think? What are we going to do next? So, Antiqui wanted to make things pulsate, and I'm down with that. Not going to do this actually right now. I mean, not going to use it in a game immediately, but let's just have some fun. Let's see if how we would do it if we wanted to make things pulsate. So let's go with ball R equals 2 plus... how are we going to do this? What's the best way to do this? Let me see real quick. Is there a counter? Whatever. Let's go frame equals 0. I mean, we could let me do this easy way to do this, because you know I don't want to get too complicated. Let's go just ball R equals ball underscore R plus 1, and it will just get huge. I want to have a huge ball. I like big balls, and I cannot lie. Oh, actually, we don't have to. Oh yeah, right. I wanted to get it down to. I'll call this. Let's just keep it everything like this. Let's just see what happens when I do. Whoa! It gets in me. I'm sorry if you got a seizure from this. I didn't want to do this. That's why I wanted to maybe reset it to 10, just so it's not. All right. So now the ball gets bigger, and it gets overwhelmingly big. So so exactly like with these things, we can do the same thing with the size of the ball. So we're gonna go like if ball dr is greater than, then we have to set like an upper limit for the ball, let's say 20, or ball dr is smaller than 1, then ball, oh actually no, it's r, not dr, sorry. Then ball r equals ball minus, oh actually now it's dr. That's the problem when you call variables in this similar way. It's very easy to get confused. All right. See, now it's getting smaller and bigger. So maybe you want to get because it should be pulsating, right? So maybe we should change it faster. We could do it by changing the speed of the dr. Let's go 2. Yeah, that's good. But now it's a bit too big. I want just to make it seem like it's pulsating, right? It should be small. So we set the upper limit for how big it can get as maximum. We set it to like 5. And the lower limit, we're gonna set at 1. Let's see how this works. Yeah, that's good. That's good. So, for example, this could be a nice effect when you hit the ball. It starts pulsating. We maybe set the lower limit down to 2. Maybe still too big. Let me just go like between 3 and 2. And now maybe the speed is too big. And you know, a lot of like things making a lot of game development is really about tweaking numbers, making sure that everything is just right. Ah, see, this looks pleasant. This doesn't look as chaotic. I think we can go with 0.5 here. See, this is nice. This is nice. I like this. So for example, this could be a nice effect for when you hit the ball and the ball like reacts to things. Alrom says all coding is scary. I don't know. I always say to my students that coding is a lot like singing or dancing, right? People say like, ooh, I'm afraid, or like giving speeches, you know, like, oh, I'm so afraid of giving speeches. And that's fine. That's okay. But I think like good things happen if you force yourself to do things. Like good things happen if you go like, I'm gonna go dancing. Sometimes you are like into dancing, right? And something I really don't like where people say like, oh, I don't dance. Or, oh, I don't sing, you know. That's like such a buzzkill. And when you're at a karaoke bar, sometimes you maybe just have to get drunk and then you will have a good time. So if you say, I don't dance, or I can't dance, right? Or I can't sing, that's the worst. Like I don't dance is okay. Like I just, it's my principle not to do this. But I can't dance is kind of like a cop-out. It says like, I can't dance, therefore I won't do it. That's stupid, right? You should, no, that's not stupid, but that's kind of like, you're saying you can't dance and therefore you won't do it. Like if you, like you have to start somewhere, right? like it's in Adventure Time. The sucking at something is the first step to being sort of good at something. So saying like coding is to me scary is fine, but you know if you want to get familiar with coding. We want to make coding not scary. We want to make coding do the things that we want it to do. And it will fail a lot of times. And every developer out there, every game programmer out there, their code fails all the time. It like failing is what programming is all about. So if you're like, oh, I don't know what to do, it's horrible, this is normal. And it's kind of like an acquired taste. You have to get used to it. Be like, relax, like, oh, it's not doing what I wanted to do. Let's figure this out. And if you think about this, like a lot of things that we do in games are actually way more complicated than actually coding. Like there's a lot of puzzle games that are very complicated. And recently we had like a lot of puzzle games that came out, like the Shenzhen thing or even Braid and Witness. These are like hardcore things. These are like super difficult to figure out. Coding is actually an environment where you're supposed to figure this out. Like you get a lot of tools with coding that help you figure this out. If you ever have any problems with Pico-8 and you're like, I don't know how this works, you just type into Google Lua and the thing that you want to make work. And then you get other people who had the same problem. And it's basically like looking at game facts and figuring out this thing that you want to make. Or you can just ask in Stack Overflow and people will rush in and give you hints on what you might be missing out. Or you can just ask in the comment section of this YouTube video and I will try to do my best to figure this out. Right, so one thing maybe also to add now that the ball is pulsating really nicely is I wanted to do two more things in this episode. First, I wanted to add sounds just because it's a good opportunity. Now we have the ball bouncing around, we want to add sounds. I'm not really good with this editor. I'm still figuring it out myself. So we're going to have to experiment this a little bit, but it's not going to be scary, guys. We're going to figure this out. So you switch to the sound editor here. This is the sound that we're editing. This is sound number 1, sound number 2, starts with 0. This is the speed of the sound, how fast the sound is playing. And these are basically different sound waves. They sound different. So let me show this. You can put it down here, and this is like basically we're putting down notes. And the height of the thing is how high the note is. The high is a high note. So for example, if you go like this, and you press space and it plays the sound. It actually doesn't have a button here, which is weird. Oh, that's nice. Or you go like this. So this could be like a jump sound, right? And you can paint the sound whatever you want. Oh, that sounds like the Mario sound where you with the shells, you know. Down here you can change the volume of the sound, so you can make it go softer and higher. You see that the bars disappear when I put it down to complete 0. Oh, even sounds even juicier now because it gets like low and soft in the middle. That's what she said. Right, I'm gonna reset the volume. Probably there's some kind of easy way to do this. And I'm going to try the different waveforms to see how things feel. Hey, that's Yoshi! Oh, that's cute! This is even a harsher sound. I don't know what you would use this for. This seems like some kind of alien. Oh, this could be a laser sound. Okay, so this is more of a... Oops. This is more of a melodic sound. What is this? Oh, this sounds like computer sound. This is more of a really crazy sound. I can tell by the sound wave. Yeah, this is like great for explosions, I think. I don't know what... I'm not a sound designer. I'm not really good with sound design myself. I usually like just record some sounds. I'm going to go with something like this, perhaps. Maybe like this. This is a bit too harsh. Can we go slower? See, if you make the speed higher... I think we need to definitely go with like 1 or something. Let me see. Maybe 2. That's too much. I think we have to go with 1. Let me see if we can make like a nice. This is all. Maybe we just need 1 tone. Let's go with just 1 tone. Yeah, that seems like punk. Oh, that's the sound I was looking for. And you know, again, as with programming, this is all, I have no idea about this. This is like the second time I'm using this program ever. It's like with video games. Sometimes you just skip the tutorial and it's like, it's gonna be fine. I'm gonna figure this out. And that's kind of the kind of attitude that we want to cultivate when we're developing games, when we're programming things like, I'm gonna figure this out. It's gonna be fine. All right. And then, you know, you see what's working and you stick to it. If it's not working, you change things around until it works. All right, so this is sound number 0. Maybe I'm gonna lower the volume. Does that work? Yeah, that works. I'm gonna make it a bit louder here, maybe. Yeah, it seems more. It seems like a ding. Cool. Right. So where is what you might be asking now. So every time we hit one of the walls, I want the sound to play. Again, we're using our how do you call it? Spickzettel in Germany. It's on the tip of my tongue. See, it's getting late. I'm forgetting things. Right. So sfx is the command for this. sfx, and then the number of the sound 0. Does it work? It works. Of course, now it only works for this wall, so we're going to put it on this wall as well. That's nice. Cool. Right. What else? I wanted to change one last thing. All right, I wanted to show you, because I had 2 things, one sounds, and the other thing I want to show you, like this is a very complicated thing. We have like an if statement for the pulsating, for the ball pulsating. This is a very complicated thing. We have a, if statement, we have a second variable. That's hardcore, man. Is there an easy way to do this? I think there is. Let's go, instead of this complicated things, we're gonna do sine, the mathematical function of sine. Which is just sin frame. A frame is a variable that doesn't exist yet. We're going to add it now. We're going to just count all the frames that we have in our game. Frame equals 0. And then here is going to go an update function is going to go frame equals frame plus 1. So we're going to take the sign of the frame, of the current frame, and we're going to add 2 to this, so it's going to pulsate around 2. Hopefully. Doesn't work. Christian, where did you go wrong? Let me remove this. Maybe this was a problem. Maybe you have to multiply it by 2 to make the impact of the sign stronger. Or maybe, because the frame is always an integer value, maybe you have to divide it by 10 or something to get some... there we go. Yeah, that was what I was looking for. See, now it's pulsating. Now we're going to multiply it by 2, so it's pulsating stronger. Yeah, see? But to be honest, I like the previous solution better. But in any case, we're just going to remove it. I just wanted to show you like a different way to do this. Like when you have something that's pulsating, it's often a good idea to use sine and cosine. And so now you have like really good control here. If you're gonna want to go make it go faster, you divide frame by less. So this is going to be now pulsating faster, and this is going to be pulsating really slow now. Now it's like almost as if it's breathing. And if you want the effect to be stronger, and softer, you divide it or multiply it by this. Let's go like this, 1.5. Should be a bit softer, the effect. Still goes to like a really tiny dot. But yeah, you would have to have like this mathematical expression. It's, you know, if it's that scary to you, just ignore it. You don't have to do it. In any case, we're gonna leave the ball size at 2 for now. We might add this effect later on down the line. I really like it how it looks. Maybe we're going to add it later on when it hits something that, you know, it kind of wobbles around. I like it. But for now, we're just going to keep the radius steady. Right, I don't think we're going to change the color as well, so we're going to delete this as well. It's just not changing anyway. It's steadily at 10. And one final thing I wanted to add is I wanted to change the screen. Yeah, let's change the screen. That's going to go like, you see how we go with circle, filled circle. We're going to go with direct fill. We're going to create a huge rectangle starting at 0, 0, that's the top left corner, going down to 127, 127, that's the bottom right corner. And the color, I want to have a deep blue. That's going to be 1. If you run this, bam. So now it says a bit more pleasant color. I kind of like it as well, because if you have frames around this, like, because I'm going to show you. Do I have it here? I don't have it here. Do I have it? This is the thing I'm usually developing Pico-8 on. It's a pocket chip. It's really great. I recommend it. I should have talked about it earlier. It costs $50. A bit more now. I got it a bit earlier. It's a $9 computer. That's a $9 computer inside a casing with a really shitty keyboard. It's a clicky keyboard. And a horrible screen. And you can see the screen is widescreen. So the Pico-8 is like in the middle here, and it has black borders around it. So if I'm developing on this and the screen is black, I don't see where the screen ends. And so changing the screen to a color that's not black helps me to see where it ends. Not a big problem here for Windows development or Mac or whatever. But I kind of also like the combination. It's a nice complementary color here. Good. Okay, so on the next episode, we kind of did a lot of like setting up here. Didn't do actually too much new stuff, just, you know, reiterating things. We did the sound thing, so that's nice. So in the next episode, we want to add interaction to it. So I want to add something I can control with the keys, by pressing keys. So that one comes next time around. Tune in next time. See you next time. Yeah! PS. Very important. We have to save this, guys. I forgot to do this. You have to save my breakout. Save it. Save it.